Hey there, ladies and gentlemen. So you got the Cornell notes for all these sections. If not, go back and do that first. This is a summary of the Cornell notes delineated into a table. So if you try to do this first, you're probably not going to understand too much. So if you kind of notice, we have a lot of pieces going on right now. We got the stuff we're doing in class. Like you got to work hard there to even be able to engage in the discussion. We got the Cornell notes going on outside of class. You got to do those to be able to talk about all the individual minutia, like the little pieces and details very well. And then you got this, which is like a summary just to help guide your thinking through this first part. So let's go. I actually want to talk about the visual, the casual parts about translations first. I know that's not traditionally how we've done this particular section, but I think we should do that first here. So if you think about a translation, think about words that can describe a translation really well. Oh, wow, what is that? Try that again. So words that describe a translation really well are words like slide, like push, move over. Okay, we can say so. Translate's a natural one to use as well. But like the thing you have to realize is that in any and all cases, you are not reorienting. Which means if you're not reorienting, which is what that word says in case you can't read my amazingly bad handwriting, is that you're not reflecting, you're not rotating, you are simply pushing one way or the other. So if it's facing left to start with, it ends up facing left to end with. If it's pointing up at the beginning, it's pointing up at the end. And that's really maybe the toughest part about all of this is that you have to, your mind is already going to this idea of combining these things, but we're not quite there yet. We're looking at the individual pieces, all right? So what does this look like sketch-wise? Well, let's say I have this triangle. I'm going to call it, no surprise, A, B, and a C. And this triangle, we're going to make orange. Why? Because I'm feeling it today. It's almost Halloween. Let's do it. So I have this triangle ABC, and I want to translate it. I want to push it. I want to move it. I want to take this guy and copy it and pasting it. So I want to take this guy, and I want to move it. Maybe I move it here. Maybe I move it there. Move it there. It doesn't really matter. I'm moving it. So I'll move it to here. So we can call the remaining points a lot of things. I'll just go ahead and keep the traditional A prime, B prime, C prime. So how do we prove this has actually been translated? Well, visually, what we have to construct are actually three vectors. You actually have the choice, and you can think about your Cornell notes while I'm talking about this. We actually have the choice. We need to construct three line segments that are all parallel and perpendicular to one another. Another word for those segments, because they are moving in the same direction, parallel, and have the same distance, we can actually use this as vectors. Okay, so either way, what you're going to have to really construct is either three vectors, which we indicate using like an arrow. It's actually not that different from an array. And we have to kind of make this realization that these vectors are the same length. In fact, I can kind of prove it to you. Well, come back here, vector. So if I kind of move this along the top triangle, notice that the arrow is pointing precisely at its translated point on the secondary triangle. So, and again, before you guys did a great job kind of realizing that I can just kind of talk about the vertices and the rest of the triangle has to follow. But in the end, that's what I have to create. Three vectors or three line segments, whichever one you want, because in the end it's really kind of no difference, that are all parallel to one another and have the same length. Okay? So if I can construct that, I definitely have a translation because that proves in a way that all my points have moved the same direction, the same amount. The algebraic rule, the Q, well, the way this is going to work out, this one has the best generalization of a rule. I have this pre-image and I'm taking it to this image by affecting X by some addition and then affecting Y by some addition. The way this is going to end up looking is that this right here is going to be your pre-image. Okay. And this guy right here is going to be your image. But it also should be noted that A and B define your vector. Wow, what letter is that? Bam! Vector. Okay? So that's something to keep in mind that we're going to be moving as that, we're going to be moving by the vector as well. The point relationship, the constructor, the Q. Well, you're going to have to construct one of two things that we can refer back to our picture to help us kind of decide what that is. And again, it's going to either be three segments of the same length that are parallel or three vectors that are exactly the same. So we can record that. So we have a choice. We can either record same vectors, which amounts to constructing parallel segments of the same length. Okay. So we talk about special notes. Everything here in the special note column has been like a general rule, and today is going to be no exception. The coordinate rule is fine as long as you can coordinate. In other words, as long as you have a grid. But you take yourself out of the grid, you still need a way to kind of give us an order. So we have T for translation. The subscript in this case is going to be the vector of the preimage is going to take us to the image. Okay. So for example, if I'm looking at this guy right here, okay, if I'm looking at this guy right here, the way I'll write that rule is that I have this translation. I have it along the vector A prime. The preimage is triangle ABC. And that will take us to the new triangle, A prime, B prime, C prime. Okay? So again, think of the algebraic rule more as an informative thing. Think about this general rule more as like an order, like this is what I need you to do. So what we got, that's it. We have notes about just about everything. Guys, this is not an easy section. You guys did a good job with all this crazy stuff about rotations, reflections. This is more information, I think, than you'd probably ever get or ever need for all this. But what this is going to allow us to do is talk about this stuff at a very, very high level. So that's what we'll be working on class on Thursday and Friday. So buckle up and get ready because that's what's coming our way. All right, so with that being said, hope you guys have a good day, good night, good evening, and we'll see you guys later. Booyah.